Hey GPT, this is Satyam here, and I am a first year student of BCA, and I am pursuing my this degree from Chandigarh University, and I am learning MLDL or AI. So I just wanna practice deep learning with you. So can you ask me some of the concept of the deep learning so I can see that how I'm good at deep learning, like explaining the concept of DL. So can you ask me the questions?
Hey Satyam, I'd love to help you practice. Let's start with something foundational. Can you explain what a neural network is and how it differs from a traditional machine learning model?
Yeah, I can tell you what is a neural network. So in the neural network, we have a neurons, and each neurons is connected to the another neurons. Basically, in like they have a layer, and layer is containing neurons, and every neuron is learning something from the data, and each layer is each layer's neuron is learning something from the data, and we have a input layer like hidden layer and also output layer. So this is a neural network where we have a neuron, and it's also have a some weight, and then we have also input, and then it is also added by the bias, which is additional parameter. So these are the things in the neural network, and in the traditional machine learning model we doesn't have these kinds of a thing like neurons. So it in the neural network we have a neurons, artificial neuron, and in the machine learning we didn't have anything like that.
That's a great explanation. You really touched on the key points the layers, neurons, weights, and bias. Just to add, in traditional ML, we often rely on handcrafted features, whereas in deep learning, these layers themselves automatically learn features from raw data. So, if you're comfortable, let me ask another one. Can you explain what backpropagation is and why it's important in training neural networks?
Yeah, I know. In the back propagation, we like in the back propagation we basically move back from the output layer to fix the weight and biases. Basically, sometime we increase the weight, and sometime we decrease the weight to reach to the global minima, because our goal is only one, is to reach to the global minima so we can reduce the overall error, and we always try to change the weight in such a way that we can get less error. So we are just changing our weights again and again, and we are just also using the chain rule of derivative, and then we have also a bias, which is an additional parameter that help us to provide the output. So these are the things that we always see in the back propagation, like log loss and optimizer.
Yeah, that's spot on. You're hitting all the key points. The chain rule is crucial because it lets us compute the gradients layer by layer, and optimizers like gradient descent adjust those weights step by step to reduce the loss. So you're doing great. If you're ready, I can ask you something a bit more advanced, like how different activation functions impact learning. What do you think?
Yeah, activation function basically we use in the neural network after, like, if we have a CNN, then we use our activation function, because some of the values is not good for our neural network. So activation function decides that which values is useful for our neural network, and which value we have to ignore, and which value we have to hold and pass forward in the neural network. So activation function, we can say, it decides which values is important for our neural network. It decides which value we have to pass and which not. So yeah, that's an activation function, and we have example like ReLU, sigmoid, TANH, and leaky ReLU, pre-ReLU. So these are the also activation functions example.
Yeah, that's a fantastic summary. Exactly. Activation functions introduce nonlinearity, which is essential so the network can learn complex patterns. And yeah, each one has its own pros and cons. Like ReLU is fast and simple, but it can suffer from dying ReLUs, while sigmoid or tanh can squash values but might saturate gradients. So you're definitely on the right track.
Yeah, activation function basically introduces non-linearity to learn complex pattern from the data.
Exactly. And that nonlinearity is what lets deep networks model really intricate relationships, things that a simple linear model just can't handle. So it sounds like you're really getting the hang of these concepts. Nice work.
Okay,
If you
so
have any,
ask me the another two questions of the deep learning, then we can end the session here.
of course. So, first question, can you explain what overfitting is in deep learning and how we can prevent it? And second, what is a convolutional layer and why is it so powerful in image processing tasks?
Okay, so overfitting in the deep learning, we have because sometime our model start learning the things about the data, or we can say it is good at training set, but it always fail on the new unseen data. So that's overfit, and for overcome from this overfit, we have to go with the dropout where we switch off the some random neurons like 30%, so it helps us to overcome from overfitting. And about the convolutional neural network, so it is basically used for images, and it is best because it has filters like maybe one filter or 64 filters or 28 filters. It basically we have a filter, and each filter learns something from the data, like each layer each filter moves over the image to extract the edges of the image, like edge of the ear edge, like vertical edge or horizontal edge, or maybe edge of the ear, nose, eyes, hair. So it is basically moving over the image, like which is our data, and it is extracting the important thing from it. So that's a convolutional neural network convolutional layer.
That's really well explained. Yeah, you nailed it. Overfitting is when the model memorizes the training data and loses generalization, and dropout is a fantastic regularization technique. And your explanation of convolutional layers is spot on. They act like little pattern pieces, detecting edges, textures, and so forth. Awesome job. If anything else comes up in your learning journey, I'm here to help.